Hello and welcome to the night class. Today we're going to study some sum and difference identities. These identities are located on your formula sheet on the left side, kind of in the middle. I believe they're identities 9, 10, 11, 12, 13, and 14. But here they are. Here's the ones we're going to concentrate on. You have the sum and difference identity for cosine. Again, these are called sum and difference because you're adding and subtracting. You have the sum and difference identity for sine, and then the sum and difference identity for tangent. So, without any further ado, let's get started. We're going to do some problems where these would come in handy. And the directions here says use the sum or difference identities to find the exact value. So I have the teacher's edition here, so you see the answers. So let's figure out how they got these answers. So we'll do let's see here, we'll do 15 and 17 and 19 and 21. And then we'll probably skip down and do 35, 37, 39, and 41. And the directions are a little different. These were verifying the identities again, which we did in one of our other videos. So let's get going. So 15 is sine of 165 degrees. Well, what we need to do is change this 165 to angles that we can do in our head or that are on our little cheat sheet for now. Like I said, we won't use the cheat sheet forever, but for now we will. So, and what am I talking about? Well, on the cheat sheet you have 120 degrees and you also have 45 degrees, and if you added those together they give you 165 degrees. So I'm changing this problem to sine of 120 plus 45. Okay, then I'm going to use, this one is sine and we're adding, so I'm going to use this one right here. Okay, alpha in my problem was 120, beta is 45, and you just basically plug it in. Okay, 120, 45, 120, and 45. Okay, so let me come up here. Sine, this will equal the sine of 120 times the cosine of 45 plus the cosine of 120 times the sine of 45. And of course, these are all degrees. Okay, so if you look at your chart, or you can also do it by hand, it's not that bad. For instance, sine of 120, you have to think about what is its reference angle. Its reference angle would be 60, so you're doing sine of 60. So if you're doing the hand trick, you got your thumb, and then 1, 2, 3, and then your pinky. That's a really bad hand, but you see what I'm doing. Okay, so we got 0, 30, 45, 60, and 90. And so we're going to use this one, okay, our pointer finger, and sine is the number of fingers to the right, so that's 1, 2, 3. So the sine of 120 is the square root of 3 over 2. Again, it's a lot easier if you just use your chart on the back of your cheat sheet. 120, however, 120 is in quadrant 2, so it's also sine. Remember, again, we're using a lot of trig here, all-star trig class. So 120 is in quadrant 2, and sine is positive in quadrant 2, so that's square root of 3 over 2. 45 would be right here. Cosine is how many fingers are to the left of 45, would be 2, so that's the square root of 2 over 2. Plus the cosine of 120 is 1/2, but it's negative 1/2. Again, I know it's negative because, again, we're in quadrant 2. The only thing that's positive is sine. And then the sine of 45 is also square root of 2 over 2. And then you just simplify those. That's square root of 6 over 4 plus negative square root of 2 over 4, and you can write those as one fraction. Square root of 6 minus square root of 2 over 4. So that's where they're getting that answer right there. Okay. 17 is, let's see here, sine of pi over 12. Sine of pi over 12. So, first thing we're going to do is make this into degrees from radians. That will be the sine of 15 degrees. And then again, we ask ourselves what of our, our angles that are on our sheet that have 0, 30, 45, 60, 90 reference angles will add up or subtract to be 15. And the answer is 45 minus 30. Now, it doesn't have to be those two. That just happens to be the two smallest ones. So this time I'm going to do the difference identity for sine. So the difference identity for sine is the sine of 45 cosine of 30 minus the cosine of 45 times the sine of 30. And then you just figure out what that is. The sine of 45 is square root of 2 over 2. The cosine of 30 is square root of 3 over 2. Minus the cosine of 45 is square root of 2 over 2. And the sine of 30 is 1/2. Again, I've basically got these memorized now, but you can use your hand or you can use the chart on the back of your cheat sheet to figure out these. So this is going to simplify to be the same answer we got on number 15. So square root of 6 minus the square root of 2 all over 4. Okay, and as you can tell, there's our answer. We got it right. Must be butter because we are on a roll. All right, 19. Same process. 19 is the cosine of negative pi over 12. Well, I just figured out pi over 12 is 15, so this is negative 15 degrees. And so basically I can use the same numbers, but I just switch them. So instead of 45 plus 30, or minus 30, 45 minus 30, I'm going to do 30 minus 45 degrees. This time I'm using the cosine, and we're doing the difference of cosine. So again, switch back just to give you an idea which one we're using. This one right here, difference of cosine right here. That's the one that we are looking at. We don't need this one on this particular problem. We're doing the cosine. All right, so plug those in. Here we go. So we're going to have cosine 30, cosine of 45, plus the sine of 30 times the sine of 45. And we plug in our numbers. That's the square root of 3 over 2. That's the square root of 2 over 2. Plus sine of 30 is 1/2. Sine of 45 is square root of 2 over 2. So that will be the square root of 6 plus the square root of 2 all over 4. And again, same answer. Okay. Easy peasy so far. 21, last one in this section, we got tangent of 23 pi over 12. Tangent of 23 pi over 12. All right, I'm going to have to use my noggin here, aka calculator, figure out what 23 times 180 divided by 12 is. So we can change this to degrees. So 23 times 180 divided by 12 is 345. So this is tangent of 345. So we can change that to the tangent. Let's see here. Well, I'll just make it easy. That'd be 300 plus 45. Okay. And now we finally get to use a tangent one. It's addition. So this time we're not using the cosine one this time. We are using the tangent of a sine of addition. So sum identity for tangent right here. This is the one we're using. Okay. So let us give it a try. Okay. So that, let's see here, that was tangent of 300 plus the tangent of 45 over 1 minus the tangent of 300 tangent of 45. Now let me make sure, just real quick, make sure I got that equation right. Yep, positive on top, negative on the bottom. We're good. Okay, so the tangent of 300, well, let's see here. Tangent of 300 would be negative square root of 3 plus tangent of 45 is 1 over 1 minus negative square root of 3 times 1. Tangents are a little harder than the sine and cosine because you usually have a little more simplifying to do. For like example, perfect example, we get negative square root of 3 plus 1 over 1 plus the square root of 3. That's the answer, but you don't want a square root on the bottom, so we're going to take and rationalize the denominator. So negative square root of 3 plus 1 over 1 plus the square root of 3. We multiply by the conjugate on the top and bottom. 1 minus square root of 3. So on the bottom, just do this. When you're doing the conjugate, you just have to do the first times the first, which would be 1. And the last times the last, which would be minus 3. On top, though, we have to multiply it all out. So that's negative square root of 3. Negative square root of 3 times negative square root of 3 is positive 3. 1 times 1 is positive 1. And 1 times negative square root of 3 is negative square root of 3. And so this is what takes the longest because you have all this simplifying to do. So 3 plus 1 in the middle here, right here, 3 plus 1 is 4. And then negative square root of 3 and negative square root of 3 is negative 2 square root of 3 divided by 1 minus 3 is negative 2. And our final answer of 4 divided by negative 2 is negative 2. Negative 2 divided by negative 2 is positive 1 square root of 3. So those are just 4 examples of how to do those. Let's skip down and let's do some of the identity problems. These are actually, I think, a little easier. Maybe I'm just crazy, but they go a little quicker. Okay, so we are, again, directions say verify that each equation is an identity. So basically we're just proving that this is true. So remember, when you're doing this, you cannot take something from one side and move it to the other. Okay, you have to work each side independently, and you're basically just trying to make them look the same. So cosine would be cosine of 60. We're going to do the addition, some identity of cosine, and the difference identity of sine is basically what's happening here. So we're going to have cosine of 60, cosine of A, minus the sine of 60, sine of A. That's the sum identity for cosine. All right. And if you work this out, cosine of 60 is, let's see here, 60, that would be 1/2 times the cosine of A minus the sine of 60 is square root of 3/2 times the sine of A. And that's about as far as we can go on that side. So now we come over here on this side and we do the difference identity for sine. Okay? So the difference identity for sine is sine of 30 cosine of A minus the cosine of 30 sine of A. And we simplify those. That will be 1/2 cosine A minus cosine of 30 is square root of 3/2 sine of A. And as soon as they look exactly alike, you will have proven that they are an identity. Okay? 37 cosine 180 plus x equals negative cosine x. So, again, do a cosine and we're adding, so we're going to be doing the sum identity for cosine, which is this one right here again. Okay, we've been using all three of these basically throughout this lesson. So, cosine over here, we'll have cosine of 180 cosine of x minus the sine of 180 times the sine of x. And the cosine of 180, if I'm not mistaken, is 0. Is that right? No. Cosine of 180 is negative 1 times cosine of x minus the sine of 180 is 0 times the sine of x. And 0 times sine of x would cancel, and we're left with negative cosine of x, which is what we were trying to get. Boom. 39. Two more. Sine of A plus B equals tangent of A plus tangent of B divided by secant A, secant B. All right, so I am going to, well, let's see here. I am going to make everything into sine and cosine first. That seems like a good idea because we got sine over here. So that's tangent of A is sine A over cosine A plus sine B over cosine B divided by secants are 1 over cosines A times 1 over cosine B. All right, then I am going to multiply because I want to get rid of this denominator on top and bottom. So I'm going to multiply the top and the bottom by the denominator, cosine A, cosine B. And when you do that on top and on the bottom, we're not changing the value of it because we're just multiplying it by 1. On the top, when we distribute here, okay, the cosines A's cancel, okay. So this goes away and this one goes away, but I'm not going to, this one right here goes away, but I'm not going to cancel it because we need it when we multiply times the second one here. So cosine A goes away on the first one, so you're left with sine A cosine B plus, and then when you multiply it by this one, the cosine B goes away, okay, and you're left with sine B times cosine A. All right. Now, you're kind of stuck here. You can't go really any further. So you can come over to the left side, and I'm just going to do the sum identity for sine, which is sine of A cosine B plus cosine A sine B. And as you can tell, those are the same thing. These two right here are in different order, but it doesn't matter because you're multiplying. So other than that, we're done. And last one we'll do for us today, 41, says secant of A minus B equals secant A, secant B on top divided by 1 plus tangent A, tangent B. So let's see here. Here we go. I'm going to do this top here again on the right. So I'm going to change that to 1 over cosine A times 1 over cosine B. It's very similar to the one we just did. It's just in reverse. 1 plus sine A over cosine A times sine B over cosine B. And we are going to work it very similar to before. We're going to multiply by the common denominator again on top and on the bottom. Again, that way we're just basically multiplying it by 1. And so on the top, when I multiply it on the top, both the cosine A cancels and the cosine B cancels, and you're just left with 1 on top. And then when we multiply here, cosine A cosine B times 1 is cosine A cosine B. And then when we multiply it by these, the cosine A and B cancel each other, and we're left with plus sine A sine B. And again, that's about as far as we can go on that one. But over here on the left, I can secant is 1 over cosine A minus B. And then I can do the difference identity for cosine. So that's going to be cosine A cosine B plus sine A sine B. Uh-oh. Sorry about that. Had a glitch. Where'd I find? Hope it didn't delete my work. Oh no, where'd it go? Well, hey, there it comes back. Okay. Phew, that was scary. Almost done. Alright, so sine B. Whew. And we now have the same thing on both sides, so we're done. Hope this video helps. Again, this is the more tedious work, but it's fun, and there is a purpose to it once you get into classes like calculus and a little more of your advanced math classes. So, hope you have a great day. Stay above the line, and we will see you next time.